because it's a repeat of that same lab, what we are doing, what we did earlier. The reason why we are doing again is for better understanding. For better understanding, we are doing this one more time. So I'm going to remove BGP from all the routers first, then we'll start fresh. Except the IP address configuration and the OSPF configuration in the middle autonomous system, all other things will be removed. So let me begin from router 1. Right now BGP is running. I can see BGP neighbor, but when I type show IP BGP, I see some network show IP BGP summary, I see some neighbor. Now removing BGP is very simple. No router BGP 10. 10 is the autonomous system we gave. You see here it is written. Not only that, you can even see here the local autonomous system number is 10. Remove, that's all. Now all finish, everything is removed. Let's check now. Show IP BGP summary, nothing is there. BGP is not active. Show BGP is not active, gone. I removed BGP. Likewise, I'm going to quickly remove BGP from all the routers using a notepad. Using notepad, you know very well, it saves a lot of time. BGP 20 is what I need to remove from router 2 to router 5. So I'm going to paste this on 2, 3, 4 and 5. Alright. Now one last router to remove BGP, which is BGP 30 on router 6. Done. What next is we are going to first do eBGP. You remember we learned, like for eBGP there is no need to form using loopback. eBGP neighbor needs to be directly connected. So we are not going to use the loopback interface of R2 and R1 to form neighbor. Likewise R6 and R5 to form neighbor. The configuration is very straightforward. On R6 I'm going to say I'm on R6 router BGP 30, neighbor 56, 56, 56, 5. That's what the IP address of router 5, and then a remote AS will be 20. And then the network that I want to advertise is 6.6.6.6, so I use the command network 6.6.6.6. In BGP you need to match with the mask on the interface. Match with the mask on the interface. So put mask command and then say mask on the interface is this. That's all. So in EIGRP and OSP we used to do wildcard mask. Here not wildcard mask, subnet mask. And in EIGRP and OSP there is no necessity to match with the mask on the interface. But here in BGP you must match with the mask. Next. Router 6 configuration is over. On router 5, router BGP 20, neighbor 56.56.56.6, remote AS 30, neighbor 56.56. Sorry, What am I doing? That's all. There's nothing more needed here. See, the neighbor has come up already. The neighbor has already come up. We can verify that by typing show IP BGP summary. You see, the neighbor is up for last 22 seconds. Up for 22 seconds. But no networks have been learned. See, prefix received is nothing. But you remember, we advertised the network there. We have advertised a network 6.6.6.6, but we are not learning it here. Maybe it takes some time. I'm waiting for this to turn into 1, means 1 prefix received. Noted. Show IP BGP will also be blank. If you learn any network, you will see it. You will see it here. But I don't see it here. The reason is, oh, now it has come. Now if I type show IP BGP, I'll see. See, I told you, it will take some time because it's TCP. It has to do the 3-way handshake every now and then send the update. Alright, so between router 5 and 6, the neighborship is up. Let's go to router 1. Router BGP 10, neighbor 12.12.12.2, remote AS will be what? 20. To this neighbor, I want to advertise a network here. Mask will be 32. Here, done. Router 1 is also configured properly. There is nothing more to do here. Let's go to router 2. Router BGP 20. Neighbor 12.12.12.1. Remote is, it's not the same 20. It's a different number. That makes this router to know that this is an eBGP. That's all. I'm expecting again show IP BGP summary and neighbor. This right now this is in idle state. It should become now it says BGP is up. Now if you go and see, it will not be idle. It says it is up for last 5 seconds and no prefix learned. It will take some time and it will show you 1 there. If you see 1, which means 1 prefix learned. So for no prefix learned, that's why show IP BGP also is blank. I'm expecting 1 here and that 1. Whatever the number, if you have 10 here, then you will see 10 subnets learned. Okay, it will come. Let me go to router 1 and check whether it is advertising it. Show IP BGP. It says I do, yes, I do run BGP. I do advertise this network. Next stop is local because I'm the owner. There is no next stop. Next stop is local. Now I'm expecting router 2 to, okay, it has got it now. Now it is 1. And it says I learn 1111 from router 1. Who is the next stop? Router 1. From which autonomous system? From autonomous system 10. And on router 5, what you learned is 6.6.6.6 came from router 6, who is in autonomous system 30. Okay. Now, in order to learn this 6.6.6.6 in router 2, there is no 6.6, and in order to learn this 1.1.1.1 in router 5, see, it's not there. You need to form IBGP between 5 and 2. Is it possible to form IBGP between 5 and 2 without having BGP in 3 and 4? Yes, it is possible. But when I ping, it won't ping. The reason is these two routers do not know about those external networks. So what we have to do is we have to do on every router. We learned it like full mesh. I need to go to router 5 and form neighbor with 3, 4 and 2. Why? Because we learned that there is a split horizon rule saying a route learned from an IBGP should not be given to another IBGP. So we will form neighbor between 5 and 2 so that 5 will directly give it to router 2. Please understand this very well. If you are not understanding this class, you need to go back to last 2 classes about the split horizon and all we spoke. Why I need to make full mesh and all we learned. So I'm going to make full mesh now. You see, router BGP handy, and I'm going to use loopback interfaces because router 5 has got 2 paths to reach router 4. It can go via router 3 or it can go directly to router 4. Likewise, router 5 has got 2 paths to reach router 2 and router 3. So whenever you got redundant path, it is recommended to use loopback interface. All this we learned. So I'm going to say neighbor 3.3.3.3 remote ASS 20. The previous class we learned that the source address should match with the neighbor's neighbor list. If not, the packet will be ignored. If match happens, then the neighborship will happen. So to source it, I use the command update source loopback 0. I believe you remember these things that we spoke in the previous class. If not, you must go through the videos, which is already available for you in the channel. Done. 3 neighbors. So what I'm going to do is I'm going to use a notepad, edit it and put it on all the other 2-3 routers. These things we didn't type, it is by default. We'll talk about this later. Now I'm going to paste this on router 2. In router 2, there are 3 neighbors. Who are they? 333, 444 and 555. So 555 is there, 333 is there, 444 is there. This is not needed. Alright, I'm going to paste this on router 2. What? Next, on router 3, I need to have neighbor 3 neighbor 555, 222 and 444. Done. And on router 4, I should have 555, 222 and 333. That's it. That's the end of our story today. If you check the lab now, it will work. The final result. Look at this. Router 3 has got 3 neighbors. One is router 2, the other one is router 4, the other one is router 5. Now, I'm going to router 6. Show IP route BGP. I am expecting 111. You see, 111 is coming all the way from router 1 to router 6. Now let me go to router 5 and check show IP BGP, you can see that 111 is learned from router 1. Yep. Though it is given by router 2, it's the AS by AS routing protocol, path vector protocol. It shows the next autonomous system IP address. Please understand, router 5 is not showing router 2's address. Though router 2 is giving to router 5, it shows the address of router 1, because for BGP, the next hop will be next autonomous system, not next router. RIP will have every router as one hop. But BGP, next hop means next autonomous system. That's why you see the IP address of router 1 on router 5. Likewise, if you go and check on router 2, show IP BGP, you see the autonomous system address, router 6 address, not router 5's address. Okay. Now, let us go to router 1 and try pinging. So you see it says here 6.6.6.6 is learned from next autonomous system, which is router 2's address. The next autonomous system is 20. That 20 autonomous system has learned it from 30. So if I now trace route or ping, I will be able to reach 6.6.6.6. But I need to source it with 1. Listen. If I simply ping, the ping will not happen. Why? When I simply ping, it will take 12 address as the source address. Exit interface address as a source address. But router 6 has got no idea about 12 network. Have we advertised the 12 network? No. Router 1 knows only 11111. So you have to source it with 11111, your loopback, which R6 can respond. See, I'm able to ping. But if you remove that 11111 and ping, the ping won't happen, because router 6 has got no idea about 12.12.12.1 from where the packet will be sourced by default. By default, when you don't mention the source, it is going to take the exit interface address. Hope you understand what I'm saying. So, one of you were asking this question, so I'm responding this. One of you did this lab and you asked me the question last time. So if you ping with source, only then it will ping. Or if you want to ping like this and get you want a response, then you need to advertise this network 12. Let me do that. Router BGP 10 network 12.12.12.0. Mask is 255.255.250. The reason why I put 255.250 is because we use only 24 here. Now, after advertising this 12 network, this ping will happen. Before that, I just want to show you that router 6 have learned 12 network. Router 6 now knows to respond to router 12 network. Ping, it will ping now. See? Pings. Please ask me question. Sounds like you understood.